Now let us quickly talk about galvanometer conversion, and to better understand it, it's best we do some exercise on series and parallel connection connected to a cell. Like this setup, your active resistor connected to this cell. Of which this cell, it is assumed that it has no internal resistance. We neglect internal resistance. So the EMF coming from the cell is 15 volts, and that 15 volts is equal to the terminal potential difference. But we are not looking at the words internal resistance. Now, if you have these three resistors or this resistance and this cell, so that providing that terminal potential difference, the first thing you can be asked, the current flow through the whole cycle, the current flowing through the whole of the circuit of this whole setup. And to get it, to calculate for it, you employ Ohm's law, that I is equal to V over R. Where this R, we are going to use the equivalent resistance because we are looking at the current flowing through the whole circuit. So we are looking at the equivalent resistance of these three resistors. So we can get that. So 1 over R eq equals to 1 over 3 plus 1 over 4 plus 1 over 5. So when you take the SCM of 3, 4, and 5, 3, 4, and 5, 3, 4, and 5, that's 1, 4, 5, that's 4, 1, 1, 5, that's 5, that's 1, that's 20, 60. 60, 3 divided 60 will give us 20. 4 divided 60, 60 divided 4 will give us 15, plus 5 divided 60. 60 divided 5 will give us 12. Will give us 12. Now 12 plus 15 plus 20 will give us 47 over 60. 1 over R eq. The R eq is equal to 60 over 47. Let's also go, we are correct. The equivalent resistance is this. So R is now equal to VV, which is the terminal potential difference. We are looking at current go balance. Now the terminal potential difference of the EMF 15 divide our R eq is 60 over 47, which is the same as 15 times 47 over 60. Now yeah, 15 here 1, 15 here 4. 60 divide 15 is 4. So current is equal to 47. 47 divided 4, that's 11.75 ampere. 11.75 ampere. 11.75 ampere. So that is the current flowing through the whole of this whole setup, this whole circuit. Now the next question that can be asked, because these three resistors are all connected in parallel, it is not this current that is going through each of these resistors. There is a current drop because they are all connected in parallel. So the next question we want to ask is what is current going through this resistor, through this resistor, and through this resistor. At R is equal to 3 ampere. We are still going to apply Ohm's law that I is equal to V over R. But this time, the R we are making use of is the resistance at that resistor. Is the resistance at that resistor. And the V we are making use of is still this 15V. Why? Because this three resistor is in parallel. And because they are in parallel and there's no internal resistance, the terminal potential difference coming from the cell will be the potential difference at each of the resistors. There is no potential drop. We have said it. The potential difference, terminal potential difference, the potential difference at each of the resistors because they are all in parallel. So our V will remain 15V over our arrow is still 15 divided 3 will give us 5 ampere. So that is the current flowing through the first resistor. While the current flowing through the second resistor will be I is equal to V arrow. This time around, the voltage is still 15V because there is no potential drop. They are at the same potential. V is still what 15 and arrow will be arrow 15. Arrow is 4 for this time. 4 equals to 15 by 4. 3.75 ampere. Now the third one has arrow is arrow equals to 5 ampere. Here present so I is equals to V over arrow. Here V is 15, arrow is what 5, E equals 3 ampere. Now if you add everything, you check it up. Add everything, 8 plus 3.75. Add this, you get this current. So we are in the right path. So the current drop here, and then because the total current that comes the resistor. So that is the second question that we asked. Now, the third question is 11.75. We're going to do that now cover this potential difference, standard potential difference. And I'm asking what current, what potential difference connected to these three resistors of those resistance that will give us this current. What is the potential difference? What value of that potential difference? So we are looking for R. We are looking for V, rather, question mark. And to do that, we still have the Ohm's law that V is equals to what? R. Now, because we are looking for the potential difference that will supply this current across the resistor, the current will now be the total current going through that setup. And I will now be 11.75 times 11.75 times ROX our equivalent resistance. Our equivalent resistance which was our equivalent resistance which was 60 over 47. 60 over 47. And when you times that, once you times that, you still arrive at R is 15 volts. If you do this, you get arrived at 15 volts. So we are still on the right track. Now doing this, let's quickly go to shunts. Let's quickly go to shunts.